Good afternoon. Good afternoon, everybody. This is Pradeep Behera from School of Engineering and Applied Sciences, the Department of Civil Engineering. I'm the chair of Civil Engineering Department. I'm pleased to welcome you all for this senior engineering design project presentations. However, we are conducting this virtually given the situation of COVID-19. I welcome you all to our presentations, and I have two teams. They will present their senior projects, and the civil engineering curriculum culminates with the capstone design course, a two-semester sequence, fall 19 and 20 spring. They offer the senior project 1 and 2, and students, basically the students takes this design project as an open-ended team-based multidisciplinary design course, and they will present their work today. And the primary emphasis is placed on the thinking process in understanding the problem, the generation of planning and design alternative solutions, and the design calculations and design of the civil engineering systems. And I request everybody to I'll just unmute the team that will present today at the first team. And I have given a link, online link, to fill up a survey at the end of the presentations of the first team. I would request, please keep your questions till the end. Okay, and I will immediately I will give, yes, team A. I'll give the team A ready. So, okay, team A, you are ready? The leader of the team A.
We're just thinking right now. We're waiting for Armani. I don't see her. She hasn't logged in yet.
Okay. We would like to start in time. Why don't you start?
Okay.
Yeah, you start your presentation. Probably she will join. Yeah.
Okay.
Yeah, she's there. She's there. Everybody's there. Please start your presentations, Jose.
That's good.
So Behera, don't forget to record.
Yes, I'm recording also.
Okay, I'm going to start.
Yes, start.
Hello, everyone, and thank you for joining today our senior project. So this is the summary of our 4 years of study, and our senior project is going to be planning and design of civil engineering systems for the Quarantinevile subdivision. And next slide. So the people who participated are here. These are the students on the left side, and our advisors are on the right side. Thanks to them, we were able to complete this perfectly and in the right way. And this is the outline that we'll be discussing on every slide. Basically, this is what we're going to be covering today on our slides in general. Next slide. Yes. So throughout our year of senior project, it wasn't just focused on one part. So we had actually many projects to complete throughout the semester. And the first project was an art. We had to go into the ACE journals, magazines, and any civil engineering magazine that has, and try to bring a project with any engineering problem and try to present it and try to study it and try to see what went wrong. So it's basically critical thinking at the same time, try to think of the way we can actually explain it and as if we went through it. So that was the next slide, please. So that was the research of civil engineering projects. Now, the examples of some of the topics we talked about and we found was Caltrans highway structures, which was talking about the earthquakes hitting California and the effect on the infrastructure and the streets. And the second one was super tall in Seoul, the first super tall building in South Korea, which was very like it had challenges and stuff like that that we had to go through from an engineering point of view. Now the third one was Tundra Mine project, which was a project and that was abandoned at some point, and that had left environmental issues because nobody was taking care of that. Next slide. So that was for the first project. Now our second project throughout the year was small site development, where we had to learn the permit and regulations process and try to understand it. And then we had to go to get calculations, actually remind ourselves of how to get runoff calculations for what was coming ahead of us. And the third part was stormwater management control. It's just to know how to control our stormwater. Next slide, please. So in this slide, this is what happened. We were giving a land and we had to develop it. We had to build on it, and we were supposed to go and understand how to get the permits. What kind of regulations are there? What's the difference between federal and state regulations? What is like how to? Why would you get that? Like all of these things and the questions we learned throughout the process. Now, second slide. Now, in terms of calculations, which was step number two, try to get the calculations for the pre-development, post-development. It's like basically what our land looked like before we took care of we took care of it and we start working on it, and how it looked like afterwards, and was it efficient, our design, or not? And we calculated that based on years, and we used an RCS method, which is very well known in the civil engineering department. Next slide, please. Now, the third main part, which is very important, is the stormwater management control plans. So yes, we have rain, climate change, we have lots of things. What's affecting us? So we have lots of water in most areas. How are we going to manage that? Because we can't just let it be all in the pipes and go into the treatment facilities. That's causing lots of damage to our infrastructure. So we learned new ways of like new rain garden, rain barrels, permeable pavers, and like all of these things that helped us understand how to control stormwaters and to manage it. Now, this is for the second part. Now, I'm going to leave you with Jose. He's going to talk about the next part. Thank you.
Hello, everyone. I will be presenting our third project, which was a hydraulics modeling project, where we were tasked to redesign this culvert existing that we took a picture of under new design flows in HECRAS, which is a modeling software. And we were first split up into subgroups where we designed 3 alternatives and were given a new design flow. And based on those, we would design 3 alternatives and select the best one under low flow velocities and under low differences in head. We would then implement that proposed design into the new original flows, where we calculated the differences in velocity and differences in head. We would compare these flow velocities and select the best alternative. And from those different numbers that we calculated, we determined that from the existing model shown above, we were to select a new model where it was pipe arches with 3 different openings. The main purpose of this project was just to get an exposure of a modeling software to determine the differences in water elevation, water velocities, and try to model different alternatives that can provide solutions to different category storms. That kind of concludes our first few projects in senior project. We'll now move on to presenting our planning and design of civil engineering systems for the quarantine subdivision. And I'll pass it on to my colleague Purna to present the layout developments.
Hello guys, I'm Purna. So I'll be talking about the layout development for our project. So for our subdivision, we needed a layout on which we could work on. Can you go to the next slide? So the way we worked it out, we were given with a piece of land which was about 27 acres in area, and it was located in Montgomery County. The land had its constraint, which included 4 lanes highway to the north, road to the east, and wetland inside. Layout. Hello, is this Bryan?
Yep.
I cannot see the slides. Yeah, so in order to build our layout, our group divided into 3 groups, each group responsible for their own alternatives, and finally deciding on the final design together as a group. So this is our first alternative, which was designed by Nabil, Khaled, and Yazeed. They came up with 26 single-family houses, 48 townhouses. We have schools, office buildings, shopping centers, and the idea of pond and wetland areas. Next slide. Okay, so this design was this alternative was designed by me, Jose, and Armani. We produced 44 single-family houses. We had laid out our office building and strip malls. We designed our roads based on the Montgomery design standards. We also followed Montgomery zoning code. And for the alternative 3, so this is our third alternative, which was designed by Hadi. He produced 57 single-family houses, 81 townhouses, office building, and commercial area. So we had these 3 layout, and we had to choose one. So our team brainstormed and decided to choose layout alternative 2, simply because the road design were according to the Montgomery County Code, and also it was like we included the ideas from layout alternative 1 and layout alternative 3 combined together and came up with this layout on your screen. So we have 56 single-family houses, 74 townhouses. We have commercial area on the north side. So after having this layout, proceeded and went ahead to our next chapters. And my friend Nabil is going to talk about our stormwater management system next.
So good evening, everyone. My name is Nabil Elkadiri, and I will be presenting you the stormwater management aspect. Next slide, please. So what we have to know is that stormwater management's main goal is that the runoff volume needs to be controlled. We need to maintain a pre-development rate of runoff, and through that develop 2 main alternatives that will allow us to do so. For the storm sewer system, the peak discharge needs to be conveyed safely to the outfall. Next slide, please. So here we have a pre-development condition and post-development conditions, and we can notice that the same process of evapotranspiration, runoff, and infiltration have been maintained. Next slide, please. So the design objective for this project is to conduct a hydraulic analysis, design hydraulic system that will convey the flow, and determine the hydraulic post-development analysis. And finally, develop those 2 stormwater management system design that are bioretentions and wetland, and figure out which one is the best alternative. Next slide. To do so, we were helped by the 2000 Maryland Stormwater Design Manual 1 and 2 and the TR55 manual. Next slide. Here is our hydraulic analysis. As we can see, we have 5 main drainage areas, runoff coefficient that we determine using TR55, rainfall depth, and the time of concentration as seen. Next slide, please. Here are 2 main alternatives, the bioretention to our left and a wetland to our right. Next slide. For the bioretention ponds, we were able to determine of the required volume and the areas for the design for each sub-drainage area 1, 2, 3, 4, 5. Next slide. Here is your criteria for the wetland, and as we can see on the right is the grading plan for the wetland. Next slide. So here are 2 layouts, the wetland versus the bioretention pond, as we can see. On the left side, all the projects runoff is going to be drained into 1 main wetland that's on the south, versus on the right side, we have 5 sub-drainage areas consisting of 5 bioretentions. Next slide. For alternative 1, the minimum surface area required exceeds the available land. Therefore, it would impact us on the engineering and economic aspect. That's why the alternative 2 is our stormwater management choice. In fact, the wetland would have a surface area of 381 feet of elevation and 19,107 square feet, which would work for our available land use. Thank you. Next slide. Next slide. For our storm drainage system, it starts at the curb and gutter, which flows to the inlet and manhole, and finally to the reinforced concrete pipes. Its main purpose is to convey the discharge from the stormy events to our wetland. Next slide, please. Finally, this is our main pipe and manhole layout. Each manhole receives a flow from a sub-drainage area and okay. And after analyzing the different routes, we were able to select the time of concentration and in rainfall intensity, which was of 7.07 inches per hour, and a peak discharge into the wetland of 93.6 cubic feet. This allowed us to come up with the following map that illustrates the entire system. Thank you very much. Now, my colleague Jose is going to present you the structural part of the project.
Hello again, everyone. I'll be presenting the structural design of our 6-story office building. Our design criteria is that we're supposed to design a 6-story office building that is composed of a steel frame, concrete slabs, and a foundation. The objectives to design our building is to first determine a layout. We would then determine the loads. We would then conduct a structural analysis and determine how the loads would be transferred, and then design our structure. We designed 3 different layouts of 3 different levels of the building, first being the very bottom level, the second being the levels 2 to 6, and the last being the roof frame. These were all drawn on AutoCAD, and all of our structural components would be designed according to the provisions for load and resistance factor design. And all the concrete would be designed according to the ACI 318 code. All our steel would be according to AIC Steel Construction Manual. And then all other relative standards like International Building Code, NFPA 2006, and then even Montgomery County's building codes would be used for reference. Here are some of the codes that we followed. Our design loads consisted of the dead loads being the structural members and the live loads being as follows. All other loads like rain, snow, and wind were determined as well. These loads would then be factored using these equations shown here. After factoring the loads, they would be applied to the floor slab, which would then apply to the floor beams, beams to girders, girders and beams to the columns, and so on and so forth down to the foundation. Now let's go through a process of designing our slab. We would take a small section and using a software called Robot Structural Analysis and checking with our Gorilla formulas that we learned, we would determine a maximum moment that would also help us determine a steel percentage. Using this steel percentage, we can then calculate and determine our main reinforcing bars and our Shrinkage reinforcing bars, this example area right there. You can see these are the results that yielded from our calculations. We can use number 3 bars at 6.5 for our main reinforcing bar, and number 3 bars at 10 inches off center for shrinkage reinforcing bars. Now to our beams. We first would have to set up a grid system, and for this example, we would have to determine the tributary area of BR02. We would then apply the factored loads from before and also consider the slab weight. We would convert this to uniform load and determine the maximum moment and then select a beam. With the selected beam, we would redesign for the moment with the weight of the member that we selected in consideration, and then select our final beam. We would go through this process through every single member here, and then finally get to our columns. We would go through a similar process for our column design. The only difference is that the compression members will depend on a slenderness ratio, and in combination with the combined load, with the applied load, we would determine the area required for these columns and then select our columns using the AIC Steel Construction Manual. For our foundation, some soil parameters were given to us in the process, and along with our foundation design methods, we determined that our spread footings or shallow footings would be 6.5 feet by 6.5 feet, and placed at a depth at least 1.5 feet to support the allowable load of 800 kips imposed by our. For our pile foundation, they would be 4.5 feet, 4 foot by 4 foot as well, and driven to a depth of 52 feet to support the allowable load. The cost of this structure was mainly just material. Our concrete is as follows, our steel is as follows, and the entire cost of our structure would be $2,245,360. I would now pass this on to Khaled to present the water supply system.
Good evening, everyone. I'm Khaled Alshammari. Mohammed and I going to present water supply system design. Next slide. Water supply distribution. Water supply distribution system, it involves. We need to supply water into subdivision to meet the demand and to make sure the pressure head meets with the water demand. Next slide. Design objective. For the first point, our objective is to supply water to the interior subdivision. The second point, to meet the demand imposed by the current and future population. The third point, we need to ensure that the pressure head it is enough to meet with the demand requirement. The last list, we will design a pipe network. Next slide. Division of the site: single-family houses, multi-family homes, office building. Next slide. Design procedure: designing 4 loops, water demand calculation for each loop, flow calculation for each loop, Hardy cross method. Next slide. In this drawing, it shows our water supply system. Next slide. Water demand. Water use, single family, the average use is 177 gallon per day. Residential multifamily, the average use is 146.6 gallon per day. The commercial is 45,000 gallon per day. Next slide. Design criteria. The fire demand is equal to 2.23 CVS, and we found the maximum daily and maximum hourly. Next slide. Size and type of the size and the types of the pipe used. Standard pipe size for the design water supply, it's for our design 8 and 12 inch. The type of the pipe that's used, the CIP. Now I'm going to pass the next slide to Mohammed.
Yeah, hello everyone. My name is Mohammed Alsubaiei. The herd cross method, we use Hessenwilliam method to get the air collection pipe of K. Next slide. Herd cross, we use this table method. Next slide. Assume a few of direction clockwise equal clockwise, and assume in fact flow through the H pipe. Collection of the head lost HF for H pipe by equal according of the single of elbow of HF compute. HQ for each pipe without requiring to the single of same dimensional equals by equal. The 4 common members element to lobes, both of 5 elements should be made of 1 of each lobe. For each object use for step 3 through the 7 required until it becomes very small for all lobes. Next one. We use for this table, you can see head cross method. And thank you. Next one. Yeah, right now I'm gonna give my friend Hadi to present sanitary water system design.
Hello, everyone. I'm talking about today about the sanitary sewer system design. This part is I'm going to be explaining it in the next slides. Next slide, please. So our design objective was we have certain number of population, and they all use water, and that water they use, we have to redirect it to be treated at some facilities. So the pipes and designing them to be efficient is that's our job. And that's what we do to serve our community. Next slide. Now, the design criteria I followed was very simple. It's based on the population. So how many people do I have on my land, like on my division, for now and for the future? Because it's very important to design it for the future, not for now. So you don't have failure in your system. Now, the second one is how many manholes, the distance between them, that's going to follow regulations. And the third thing is some engineering knowledge. That's what we applied. Next slide, please. So our design procedure was like it came from different things. So it came from the book. It came from what we have been taught in our classes. And it just basically to find the diameter of your pipe. Would it be enough? Would it be sufficient? Find the velocity of your flow. Would it be cleaning itself, or do we need pump for the to pump the sewer? Or what is the slope? Can we use gravity for that? Like basically, it's all engineering terms, and that's what we applied. Next slide, please. Now, the equations that we used were mainly focused on Manning's equation. That small equation at the start, at the top, that is an equation that could be changed into many different ways to find many different things, like diameter, like velocity, like area, like flow, all of that. Now, the second one is population. The third one is to find the elevation. Next slide, please. These are my calculations. So this is what I found. For the current population, I had only 1,500 people, but for the future population, that's when I went up to, after 50 years, it would be 2,300 people just in that division. So that was my design. Next slide. My design was based on that. Of course, I found how much people are, how much water are people consuming. So I know based on that how much the discharge is going to be, how much are they letting go and letting be in the pipes afterwards. Next slide. And finally, I had to find the slope, and which means like the pipe, is it going down? Is it going upwards? Is it going straight? Based on that, gravity would help me, and then I would be able to find the velocity based on that. And then after all, at the end, I had to find the cost of my pipes based on the diameter and how much they cost on the market. Next slide, please. So for my drawings, as you can see here, in pink, it shows the pipe system, how it's going out of the houses, how it's going out of the office building, and how it's getting, all of them are engaging in the main pipe that is going all into one outlet outside of my division. That's going to be leading to the treatment facility. Next slide, please. Now, in conclusion, we have three things here to conclude. The first one was sanitary sewer system is part of sustainability. So yes, we are using water. Yes, we are doing lots of things, but is it sustainable? Like, we are hurting environment. So if we actually let go of our sewer into the soil, into the environment, we are hurting the environment. So that's a part of the EPA, Environmental Protection Agency, where trying to, whatever we use, basically give the environment the same thing in a nice way and not to hurt the environment. The second one is sanitary sewer system is part of the infrastructure. That's what, like any system, any city, any town, the first thing you want to think about before you make any town and build it, the sanitary system. That's very important. Now, the third thing is sanitary sewer system is critical for public health and safety, because let's say you were you don't have good system. You don't have like a big enough pipe to take your discharge. What's going to happen when you use your shower? That water is going to come up in your bathroom. That water is going to come up in your kitchen, and that is very important because if public complains, that's going to be a really big problem for us. So that was for the sanitary system design. And now I'm going to leave you with the transportation with Armani. Thank you for listening.
Good afternoon. My name is Armani Pretlow, and I will be presenting the transportation design for the small town Quarantinevile. Next slide. In this picture is our road network and of our layout. It displays our transit system, lane markings, and signals. Next slide. Public right-of-way. Within our layout, we had to design a right-of-way. The right-of-way grants access to different cross-sections and other parts of lands. Next slide. Here is the cross-section of the minor arterial roads within our layout. Next slide. On the left is the roundabout cross-sections, and on the right is the driveway cross-sections. Next slide. A traffic impact study was conducted in our town by zone in order to accommodate the planned traffic. Here is a chart of the number of vehicles leaving and entering within 1 peak hour. Next slide. For parking within our layout, we use the minimum number of required parking spaces by Montgomery County. Next slide. Here in this chart is our total parking demand. Next slide. Using AASHTO, which is also known as the American Association of State Highway Officials and Federal Highway Administration policies, we're able to determine geometric parameters, one being horizontal curve. Next slide. Here is a chart of the horizontal curves and super elevations of roads within our layout that has sharp turns. Next slide. Using Montgomery County transit system, which is operated by WMATA bus service and Montgomery County demographics, we were able to create a bus service on the roads, circle in red, which are Graduate Road and Civil Road. And that will be all for our transportation design.
Okay, thank you so much, Armani. So let's talk some business. My name is Yazeed Alhawti, and today I would like to present the planning and scheduling and construction project management and cost of development. Next slide, please. So here's a little information about our project. The name of our large site development is Quarantinevile subdivision, and he showed the start date of the project and end date and our client, which is our professors. Next slide, please. And this sheet shows how we split the work between us as engineers. Next slide, please. So design objectives. So first, our first objective is planning and scheduling. So to make sure that our project is going on time, we have used Primavera P6, a software that helped to determine what tasks need to get done and which resources, and a team member will be allocated complete these tasks in time. And the project is made of many tasks, and each task is giving a start and end or due date, and every activity is scheduled in a timeline for tracking and construction for the construction part. Once the tasks are defined, we will know about the risk and opportunities coming ahead. Next slide, please. So for the second objective, construction project management, to make sure that the right construction specification specifying the cost to be in occur at the completion of the project. Yes, next slide, please. Okay, so cost estimate. So our cost estimate varies with the labor and use of construction equipment and heavy machinery, as their renting cost could be very high per day. So we are planning and designing the cost based on such equipment and machinery in advance. So our project activity goes smoothly without keeping those equipment in waiting. And next slide, please. So this sheet shows our plan activities used by Primavera P6. And so all the activities were linked with each other using start to start or finish to finish logic. If one task get delayed because of some reason, all the following tasks will also get delayed, and our project will be ultimately delayed. The software helps with calculating the delayed date of the finish. Second slide. So cost estimate. So cost estimate are prepared using Excel sheet. The main component of the cost estimate are, you can go to the next slide. So the main component of the cost estimate are description of work cost, each task, and quantity. You can go also to the next slide. And the work that need to be done. So the cost was calculated based on the land cost per square foot, following the Department of Permitting. So as you can see, our construction cost for each building type. Next slide. And here a little cost summary of all the system design we had. So give you a better illustration of how much it costs to build a subdivision or like more subdivision. And that's all for me. Thank you.
That concludes our presentation. Thank you all very much. Any questions?
Okay. Thank you, everybody. Thank you, everybody, for attending our first team presentations. I'm pleased to say that a number of our civil engineering advisory board members are participating and they're observing your presentations. Any questions? Briefly, we can continue. Yes. So any questions?
Pradeep?
Yes. Yes, please.
I just want to tell you, this is an awesome project and it's awesome. I'm looking at it and I'm trying to find holes. I didn't find any holes in this process, in this and what was being done. It's just truly magnificent work. I applaud you and the rest of the faculty and students. Thank you for allowing me this experience.
Thank you very much. Thank you very much, Howard. We really appreciate your comments. And please take a note to fill up the survey forms. I appreciate, yes, please fill up the survey form so that in a few minutes, I will start the next presentation.
Okay.
How many more presentations we have?
Only two. The first team is done. The second team will present now.
Can you give us a few minutes to fill out the forms?
The form is in the chat room, in the chat. Yeah. Or the form can be, yeah. This form can be clicked and so, yeah. Our